Hey, what's up? Let's do some math today. In this video, we're going to talk about solutions to equations. So now that we're kind of doing more complex equations, what we end up getting is times when we might have variables on both sides of the equation. And when we move things over, the variables may or may not cancel each other out. And this is going to lead us to several different sort of cases, if you will. So I'm calling it 3.5 types. Really, it's 3, but I'll explain why there's a half in a little bit. All right, now the first one is the one that's going to happen more often than not. Like this is seriously 95% of the time, and we're going to call it just sort of a normal solution. And that is where x equals some number, okay? So for example, this little equation I cooked up here, 2x plus 5 is equal to 3x minus 6. Subtract 2x from both sides, add 6. We have 11 is equal to x, so x equals 11. Totally normal, okay? And it's no different if, x was equal to, let's just say, negative 15 over 4, if x equals 1.35, whatever it might be. These are your normal solutions, and we've been dealing with this for the longest time now. Now, one of the special cases we have is no solution. All right? And let's take a look at this equation. 2x plus 5 is equal to 2x minus 3. If we were to go about solving this, we would subtract 2x from both sides, and we're left with 5 equals negative 3. This is an incorrect statement. It is false. It does not make sense. If that is the case, you have no solution. So our answer would simply be no solution. And so what we're looking for is when we are working with our equations, we're solving, and we get a to equal b. And a and b are different numbers. They shouldn't be equal to each other. That's when we know we have no solution. Now let's compare that to our third option, which is really hard to write out. Infinite number of solutions. Sometimes you might see like this fancy R for all real numbers is another way to say it. For my students, I usually tell them to abbreviate INS, just say, INS, infinite number of solutions. And that's in a situation where we have something like 2x plus 5 equals 2x plus 5. You subtract 2x from both sides, and here we have 5 equals 5. That's a true statement. That makes sense. So we would say we have an infinite number of solutions. And so ultimately what we're going to be looking for here is if we have A equals A. Now, let's just kind of clarify some stuff here. The no solution or infinite number of solutions only happens when variables cancel out. All right, so take a look at what happened here. We had two x's on both sides of the equation that canceled each other out. That's what led to us having potentially no solution or an infinite number of solutions. The 0.5 I was referencing for the types we have is when we have something like this. 2x plus 5 is equal to x plus 5. We go about solving, you subtract x, you subtract x, you subtract 5, you subtract 5, we have x equals 0. This tends to throw students off. This is why I'm kind of almost giving it its own little special category, or at least I want to talk about it in more length. This is normal. It's no different than x equals 11. But since, it tends to kind of look very familiar to things that are happening over here, students think that, oh, this is a special case. I hate to break it to you, but this is not special. This is normal. So only when the variables cancel out do we have, oops, I'm still on my eraser. Only when we have the variables cancel out do we have that no solution or infinite number of solutions as a possibility. Now, you might be looking at this and be like, dude, this is obvious. Like 2x plus 5, 2x minus 3, I get it. But the thing is, it's not always going to be that clear. So let me show you some examples. And all we're trying to do here is determine if we have a normal solution we have no solution, or we have an infinite number of solutions. Some of them can be very straightforward, like this, where maybe like you're looking at it and be like, hey, this is going to cancel out. 5x cancels out. We can even cancel out the 8's. We get 0 equals 0. That's a true statement. So this one will be an infinite number of solutions. Other times, though, it's going to be hidden, like this, where maybe we have to distribute first and see what happens. So when I distribute, I'll get 12x plus 4 is equal to 12x plus 18. Now you might be able to pick up on what it should be, but we'll subtract 12x to make sure we get it. 4 equals 18. That's false. That doesn't work. So this is going to be a no solution problem. There's nothing I can plug into x that will make this equation true. Finally, or not finally, we got a couple more we're going to look at. Let's look at this one. So let's subtract 6x from both sides. And here I have x plus 10 is equal to 10. This is that special or pseudo special case I was talking about, where we have x equals 0. That's a normal solution. Nothing wrong with that at all. Okay, so this is just totally normal. Finally, let's take a look at this guy. So here, combine our like terms, we have 9x plus 2 distribute is equal to 12 minus 9x. And here's where we need to be careful. A lot of students are going to see negative 9x, positive 9x, and be like, ha, they cancel each other out, and we're going to have a no solution problem because 2 doesn't equal 12. But that is not the case. Add 9x to both sides, and we get 18x plus 2 equals 12. In other words, this is a totally normal problem that's going to have one solution. So again, as we're getting to more advanced and complex equations, we are running into a situation where we might have several different types of answers. More often than not, and again, I cannot stress this, it's going to be completely normal. You're going to get a number. But occasionally, we're going to run into a no solution problem or an infinite number of solutions problems. And as you continue to advance in math classes, you're going to see these ideas pop up in a slightly different way. But the big thing is, variables need to cancel out for that to happen. So, good luck with your practice, and let me know if you have any questions.